In this video, we're going to talk about how the derivative itself is actually a function. That is to say, if you think about it, if you think about a graph, as you move along that graph, the slope of the tangent lines is going to change. And so the idea is that as you choose different x values, f prime of x is going to actually change along the graph. So let's look at how that change actually happens. What we're going to do here is consider this function f of x, and we're going to look at different x values and see how the derivative changes, and then we're going to sketch f prime of x. So we're going to actually gather some points along the way. Okay? So recall, f prime of x is the slope of the tangent line. So if we want to find f prime of -3, let's say, then what I would say is that -3 at this value here, we want to estimate the slope of that tangent line. And I would estimate maybe that slope, it's definitely a positive slope and it's fairly steep. I'm going to estimate maybe it's like 2. So that's going to be a point on our sketch of the graph, -3, 2. Okay, then we want to continue. We're going to estimate it at -2. So just kind of allow me to section this off, if you will. So let's do like this. Okay, so at -2, we want to figure out what is the slope of that tangent line. Now I would say that that's, again, a positive value. So I'm going to guess f prime of -2 is a smaller positive value than the previous one. I'm going to guess it's like 1/2. So that's a point. -2, 1/2. At -1, when x is -1, now all of a sudden we get, a negative slope, a negative tangent line. So at x equals -1, I'm going to guess that f prime of -1 is like -1/2, right? I mean, that's, if you consider this line up here, that's definitely a negative slope, but it's not super steep. So we're going to guess that's -1, -1/2. F prime of 0. Here we're getting a slightly steeper tangent line and definitely negative. I'm going to guess that that's like -1. So 0, -1. F prime of 1. So if I look at 1, still in the negatives, right? Or I would guess about the same as the last one, maybe about -1. At 2, still negative, but not as steep. So f prime of 2, I'm going to guess that's about -1/2. So 2, -1/2. Oh, I just realized I made a mistake here. This point would be +1, -1, right? Okay, and for f prime of 3, when we get to 3, notice that we're turning back to the positive values again. It's increasing again. So I'm going to guess f prime of 3 is about 1/2. So what all of these points do is they allow me to sketch what I think the graph of the derivative is going to look like. So I'm going to put points at all these values. At -3, we guessed it was 2. At -2, we guessed it was 1/2. At -1, we guessed it was -1/2. At 0, we guessed it was -1. At +1, we guessed it was still -1. At 2, negative 1/2. And at 3, we guessed it was positive 1/2. And so if you connect those with a smooth curve, this would be the graph of f prime of x. So the important thing is that you understand where these values are coming from. That those are the slopes at those particular x values. So we're going to look at a simpler way to sketch the graph. So hopefully we understand that the idea is that at that point, the derivative is the slope of the tangent line. But we're going to use another fact here. Actually, we're going to use two facts. Number one, the slope of a horizontal line equals 0. And then the additional fact here, there's kind of two of them. If f of x is increasing, then f prime of x is positive. That's something we discussed previously. We also said, okay, if f of x is decreasing, then f prime of x is negative. Okay, so let's talk about this first point. The slope of a horizontal line equals 0. So if I look at this point here, you would have a horizontal tangent line. That means at that point, f prime of x is 0. If I look at this point over here, again, f prime of x is 0. Okay, so that gives me two dots to sketch. So I started with this first fact to get those 2 points. That's where the tangent line is 0. Next, if f of x is increasing, then the derivative is positive. Well, if you notice, all during this time here, the function is increasing. What that means is everywhere that blue is, all during that time, for all of those x values, the derivative actually must be positive if I'm graphing f prime of x. Okay? And then if I look over here on the right side, during all this time, f prime of x is also positive because the function is increasing. Okay? If I use the fact that when f of x is decreasing, f prime of x is negative. Okay, so now we're talking about this time in here. During all this time, f prime of x is negative. So I would be in the negative values. So this green right here, this is my f prime of x. I actually made a sketch, and it would be very similar to that previous function. I would encourage you to take a second and look back at the one that we just did, and you'll see that you ended up, the green graphs are going to be very similar. So you can graph by going point by point and thinking about what the slope of the tangent line is. Or you can use these two facts, that if the slope of the horizontal tangent line, or find all the horizontal tangent lines, I should say, all those slopes are 0. And then anytime f of x is increasing, it's positive. Anytime f of x is decreasing, the first derivative is negative. Okay, in this example, we're going to look at how we can estimate the derivative throughout something using a table. And so there's two options. We can use the values to the left of what we want to approximate, or the values to the right. So what we're going to do is the slope between all these points and estimate, or try and use to the left or to the right to estimate what we think the slope is. So let's say we want to find the values for c prime of t using left-hand approximations when possible. So in other words, what I'd like to do, if I want to estimate the derivative at 0, I would like to use the point to the left. But you notice there isn't one. So in this case, to start, we'd actually have to use the point to the right. So I'm going to estimate c prime of 0 equals, and so again, I'd have to use the point to the right because I don't have one to the left. 0.85 minus 0.84 over 0.1 minus 0. And if we work that math out, you'll actually get 0.1. So we're going to estimate this derivative 0.1. So to estimate c prime of 0.1, the next point, again, I want to use the value to the left. So to find this one, I would say 0.85 minus 0.84 over 0.1 minus 0 is 0.1. And so those values repeated because I didn't have a value to the left of 0 to use. So let's think, if I wanted to find c prime of 0.2, again, I would need to use a value to the left of it to do a left-hand approximation. So I would say that that's 0.93 minus 0.85 over 0.2 minus 0.1. And I'd say c prime of 0.2, and again this is an estimate, and here I'd get 0.8. So this time I'd like you to take a second and see if you could figure out what you think those other three will actually be using left-hand approximations. So now might be a good time. Pause your video and see if you can figure out those other three. Okay, so hopefully you took a second to do that. And for 0.3, we would use the value again to the left, and you would get 0.6. For 0.4, you would use the value to the left of 0.99, you get 0.6. And interesting enough, this last one, for 0.5, if you use the value to the left, you'll get negative 0.4. Okay, now we're going to try using right-hand approximation. So if I was going to estimate the slope for t is 0, then I would actually have to use the value to the right. So doing a right-hand approximation for c prime of 0, I would actually use 0.85 minus 0.84 over 0.1 minus 0, and that would give me 0.1. If I was going to estimate c prime of 0.1, again the blue, if I'm using that to show to the right, c prime of 0.1 would be 0.93 minus 0.85 over 0.2 minus 0.1, which would give me 0.8. So this time, try and pause your video and see if you can finish it out for the right-hand approximations. Okay, so if we're looking at the values to the right, then we get this is 0.6. We get another 0.6. This is negative 0.4. But if I want to estimate this last one, 0.5, there is no value to the right, so I'd have to actually repeat with the value to the left. And so this negative 0.4 would repeat. So if we want to estimate c prime of 0.2, let's say, from our table, well, we know what's happening to the right of it and to the left of it. And we would just take the average of those two. So I would take the average of 0.8 plus 0.6 over 2. I would guess C prime of 0.2 is about 0.7.